Okay, welcome to our second lesson for statistic 1, which is permutation and combination. I think you should be you should be quite familiar with these two terms, which you already learned it in your IG additional max, so as SPM and max also. So today I'm not going to go through all the basic knowledge like why you are doing factorial and so on. I want to focus more on the application part, like how to answer the question, and then I'm just going to go through a very quick one. Okay, so we will use two lessons to cover this chapter, which mean today's lesson and Friday's lesson. Then we are going to finish this chapter. So for today's lesson, we'll be focusing on the arrangement of the objects in a line, including those involving repetition and restriction. So meaning that today we'll be dealing with the situation where you are going to selecting and arranging n objects. So meaning if you have 10, then meaning you are going to arrange all 10. So for the situation like NPR and NCR, which you deal with permutation and combination, like if you have 5 objects, then you are just going to select 3 or just going to arrange 3. So for that part, we'll be covering it on Friday. So today I want to talk about the simple operation and how do you deal with it if you have the situation like repeat or restriction. Okay, so just a very quick one, a brief introduction on the thing that you already learned before this. So this topic is basically about how you select and how you arrange object. So a selection of objects is called as combination when the order doesn't matter. So for the order of the selection does matter is called permutation. So for example, if you have something like A, B, C, okay, so when you are going to put them into a pair, what is combination mean? So combination meaning when I put A and B together, is the same thing as I put B and A together. So the order or the arrangement doesn't matter. Okay, so AB is one combination, and then AC is another combination, then BC is another combination. So meaning that I know I can arrange it in BA, but it's considered as one combination only. So AB consider one, AC consider another one, BC consider another one. So when we talk about permutation, we say that the order of the selection actually matter. So meaning when I write AB and BA is going to be different thing, because I am considering about the probability of me arranging it also. So AB, BA is considered 2, and then after that I have AC and also CA, and then BC and CB. So like this, you can see the difference between this. Combination is how you select thing. So whether which one I put first, which one I put at the second, it means the same for me. But permutation, the arrangement actually matters. So meaning how do I arrange it actually make difference in permutation. Okay, so you can go through the notes by yourself. Okay, so today we are just going to learn about how to arrange n objects from n objects only. So we don't talk about R objects from n objects first. That's mean we are going to arrange everything so far for today. Okay, so the first thing that you already learned before is called factorial. So what is factorial mean? I think you should have been quite familiar with this because we learned this in binomial expression also. So factorial meaning if you have something, then you are going to multiply everything, then n minus 1, n minus 2, and continue until you get 3, 2, 1, right? Okay, so if you have a 5 factorial, meaning that you will be doing 5 times 4 times 3 times 2 times 1. That's what factorial is. And something to note here is when 0 factorial is going to be 1. So 0 factorial meaning you have nothing to arrange. So how many arrangement you have is only 1, because the one arrangement is nothing. So that's why 0 factorial will be 1. This is something that you might take note of. Okay, then the other one is permutation. We'll talk about this in a more detailed way tomorrow, but just to let you know, NPN and n factorial actually means the same thing. So out of the 10 objects, I'm going to arrange n objects also. So npn and n factorial means the same thing. So for today, I will prefer that we all use n factorial only. So for today's exercise also, you try to do everything without using permutation. Then I want you to like get used to this idea then before we move on for permutation and combination on Friday. Okay, so yeah, I think we can start with the example. So for the first one, we are going to do this like real quick because yeah, it's something that you already know. Okay, so 4 factorial divided by 2 factorial minus 3 factorial. Okay, so you need to try to learn this without using calculator. So we are at example 1 here. Yeah, because this is like a little bit down, so I'm going to write it on my paper. Okay, so same thing. If you know that later you are going to simplify this, then what you can do is like 4 times 3 times 2 factorial divided by 2 factorial times minus 3 factorial. Okay, so 2 factorial, 2 factorial. Then you can cancel out 4 times 3, you get 12. Then minus, this one is basically 3 times 2 times 1, right? So 12 minus 6, then you will be getting 6. Okay, that's settled for A. Okay, then after that B. So same thing. So you can see 4 factorial and 3 factorial here. So what you can try to do is to expand the one that you have first. Okay, so you can see 3 factorial, and actually 3 factorial is included in 4 factorial also. So that's why 7 times 4 times 3 factorial. Okay, then plus 21 times 3 factorial. So I can see 3 factorial, then that will ease my process. So I can start to do factorization or simplification. So 7 and 21, I have the same factor, which is 7. So I can bring out 7. Then after that, 3 factorial and 3 factorial also. So I can bring out 3 factorial. Okay, then after that, I can start to put my bracket. So 7 and 3 factorial, I left with 4. And then after that here, 21. So I have 7 times 3 equals to 21. So that's why plus 3. Okay, then 3 factorial, then don't have already lah. So 7 times 3 factorial times 7. So I get 49 times 3 times 2, which will gives me the answer 294. Yeah, correct. Okay, 294. Okay, move on to C. So 10 factorial divided by 8 factorial plus 9 factorial divided by 7 factorial. So 10, 9, 8 factorial divided by 8 factorial plus 9 times 8 times 7 divided by 7 factorial. So here, and here. So I left with 90 plus 72, which gives me 162. Is that alright? Yeah. So try to learn to do everything without calculator, then you will understand it like better if you need to solve question like this. Okay, so let's move on for number 2. Okay, number 2. In how many ways can 5 people sit on a row of 5 chairs? So I think for the first time I'm going to like explain it like very quick. Okay, so a row of 5 chairs, so meaning I have 1, 2, 3, 4, 5. So I have 5 space or like 5 chairs here to be filled. So if I have like 5 persons, so what happened? The first chair, how many choices do I have? So before that, then all the seats are not filled yet, right? I have 5 people, so when I want to arrange it, meaning the first seat, I will have 5 choices, correct? So like either any 5 of them can actually sit at that place. Then after that, when somebody sit here already, meaning now how many people waiting to sit? It's like 4. So that's why 4. So after 1 people sit in this place, then after that you left with 3, then 2, then 1. Okay, so that's why your answer will be the first one, the probability, the number of arrangement that you have is actually like 5, then the second one left with 4, 3, 2, 1, which this is basically 5 factorial, so which will gives you the answer here, like 5 factorial will be equals to 120. Okay, so the number arrangement is 120. Okay, so how many number 3? how many ways can the letter of the word Cambridge can be arranged? So you can try to see Cambridge. So you have C, A, okay, I'll write down C, A, M, B, R, I, D, G, E. So what you can realize is all this letter actually doesn't repeat. It's like all distinct objects. So that's why when you want to put in the, if you have like the spaces here, and when you want to put in, then meaning you have 2, 4, 6, 8, 9. So the first one you have 9 choices. After you put in one letter, then like for example, if I put in C, then after that you're left with 8, then 7, then 8, 9, and so on. So that's why this will be 9 factorial. So which will gives me the answer 3, 6, 2, 8, 8, 0. Okay. The next one, in how many ways can 9 elephants and 4 mice be arranged in a line? So you see there's no restriction also, then you have all kind of like different elephant and different mice. So if you want to arrange them in a line, that meaning how many objects you have in total, then it will be 13. So that's why 13 factorial equals to 622702080. Okay, I think I shouldn't go with the part that how to press factorial, like you should know how to do it in your calculator. Alright, okay, so that's it for the part that without restriction. Okay, that's like pretty easy lah. You just like how many things that you are going to arrange, and after that you put a factorial, then you get your answer. Okay, so let's move on to the second one, the permutation of n distinct objects with restriction. Okay, so now given this, right, okay, you can see there are 3 girls and 2 boys that are going to sit on a row of a 5 chair. So meaning that if you have something like 1, 2, 3, 4, 5, so 5 chairs here. So the first scenario is that they can take any seat that they want. So meaning that they can sit wherever that they want to sit here. So the arrangement that you might have is like 5 factorial, because I don't have any restrictions. So the first one, anyone can sit here, that's mean like 5, then 4, 3, 2, 1. Then after that you see the scenario 2, the person with the same gender cannot sit next to each other. So you can try to imagine if when you have this restriction, then what happened, meaning like if this place is actually seated by a girl, then the next one, can a girl sit here? Cannot, then it must be boy. Then if a boy sit here, then meaning the next one must be girl also. So with the restriction, you realize that the number that you have for each of the space, before this you are having like 5, 4, 3, 2, 1, right? But now if you want to put a girl in the first place, meaning that how many chances that you have? You only have like 3 girls here, so that's why you have 3 choices. Then after that, you need to put a boy here, that means you need 2 boys. Okay, you can choose from 2 boys. Then after that, 1 girl seated here already, then you left with 2, and here is like another girl here. Then the boy here, you also left with 1. Okay, so from here, you can realize that actually the chances that you are having from each space is actually lesser. So that's why I write that the number of the possible arrangement of objects is reduced if there is restriction. Okay, so as a general rule, when we want to solve something like this, right, we need to start with the part that is actually restricted. So after you check that, then after that you can move on for the part that is unrestricted. Okay, so in simple words, meaning that you should solve for the part that you are having restriction. Then after that, you go to the part that actually you can do anything freely. Okay, maybe you look at the example. Okay, how many ways can the letters of the word young be arranged so that it is not a vowel at either end? Okay, so imagine you have young here, so meaning I have 1, 2, 3, 4, 5. Okay, so there are 5 spaces here, and I'm going to arrange for the word young. Okay, no vowel at either end, so meaning that at the end, in another word, at the end, I should have consonant. Okay, so in this case, right, Y-O-U-N-G, then how many consonants you have? You have Y, N, and G. Then O and U is like the vowel, right? So for the first place, because this is the N, then this is our N also. So you can try to imagine if now the n cannot be vowel, meaning that I need to put y, n, and g. So for the first one, then how many choices I have? I have y, n, and g. Correct? Okay, so meaning imagine if I have 3 choices here and I already put 1 here, meaning how many chances do I have at the end here? So like I also have y and g, but what happened is after I put 1 at the front, then after that I'll be cancelled off 1, right? So I will left with 2 choices. Then after that, the other one is the part that actually is not restricted, so you can write anything that you want. So after you put in 1 here and 1 here, meaning how many how many letters that you left? You left with 3. So that's why 3, 2, 1. So in short, you can answer it as 3 times 2 times 3 factorial. So which will gives you the answer 3 times 2, 3 factorial is 6. Then gives you the answer 36. Is that okay? So you start with either part. So for this one, you do not need to like do it separately because the end and the starting is like the same. So if you start from the end, then you have 3 choices. Then after that, you move to the front, then you have 2 choices. Then it's going to give you the exactly same answer. Okay, so number 1, 36. Okay, so move on to the next one. Okay, given the number 2, 3, 5, 7, and then how many 4 number digits can be formed is if there is no restriction. Okay, so we start with the no restriction first. So you have 4 number here, 2, 3, 5, 7, and you are going to form a 4-digit number. So 1, 2, 3, 4. So the first one, you have 4 spaces, 3, 2, 1. So easy, 4 factorial equals to 4 times 6, you get 24. Okay, so finish for number 1. Okay, B, the number must be an odd number. Okay, so now you have the spaces like this, right? Okay, so can you try to think if you want to actually create an odd number, so which is the part that actually determine whether this number is an odd number or not? Yeah, so of course it's not the first one. I mean, any number that you put here, it doesn't make your number to become even or odd. So the number that is like critical or the one that actually decide whether it's an odd number or even number is the last one. So you have 2, 3, 5, and 7. So which number that you need to put here so that this number become odd number? Then you have 3 choices here, 3, 5, and 7. Correct? Yeah, I mean you cannot put 2 here because when you put 2 here and when the number ends with 2, then it will be an even number already. Okay, so for an odd number, you need 3, 5, 7 here. So meaning how many choices that you have for the last space? So 1, 2, 3, 3. So the same thing, 1 is selected to be at the last place already. Now you can move on for the unrestricted place. So you already pick 1 here, meaning how many choices you left? You left 3. So that's why 3, 2, 1. So in a short one, meaning 3 times 3 factorial equals to 3 times 6, which gives you 18. Okay? I'm sorry. It's totally fine if you want to write your answer 3 times 3 times 2 times 1 also. Yeah, it's not necessary that you must write your answer in factorial form. Like this, even sometimes you do not want to write factorial, you want to write 4 times 3 times 2 times 1 is totally fine. Okay? So C, the number must be an odd number and is greater than 3000. Okay, this question is like very similar to B, but now you have like 2 restrictions. The first one is the number is an odd number. The second one is like the number needs to be greater than 3000. Okay, so now the same thing, we try to draw the box. So 1, 2, 3, 4. Okay, so for this number to be an odd number, just now we say already you have 3 choices here, which is 3, 5, and 7. Okay, but now the number needs to be greater than 3000. So what is the number that you should put at front so that this number will get greater than 3000? Okay, can you put 2? No, something that start with 2, of course, it is lesser than 3000, right? Then when you start, can you start with 3? Yeah, because you don't have any number that's like getting to be like 3000. There's no probability like that. So that's why you can actually do 3 here, then 5 also. When it's 5 here, it's of course greater than 3000. And then after that, 7. Okay, so what you can realize here is you have totally the same choices for the front and the end, which is like the same thing when we deal with the question the yang just now. So you do not need to like separate, do it separately, because whether you start from the front or you start from the back is going to be the same. Okay, so maybe for this one, okay, we start from the front. So 3, 5, 7, you have 3 choices here. So imagine you pick one and put it here already, then how many choices you left for the end? You left with 2. Okay, then after that you put in this 2 number already, then you left with 2 choices, right, for this unrestricted space. So it's going to be 2, 1. Okay, so you can just write 3 times 2 times 2 times 1. Okay, which gives you the answer 12. Okay, alright, next one, go to D. So the same thing, you try to draw a space here. Okay, so this is odd number, but it's greater than 5000. Okay, so what is the choices that we have? So for the last part, it's still the same, 3, 5, and 7. For the first part, greater than 5000, then you are having 5 and 7. Okay, so now you realize that there's something different here. So before this, all the question that we have is like, we have 2 restricted parts, but then the choices that we have for these 2 restricted parts is the same. So that's why when I start at the back or I start from the front, it's going to be the same. But this one, I have different. So how is that going to affect your decision is that when you look at this, if I start from the front, right, then it's totally fine, because if I choose 5, then how many choices I left here? I left 2, correct? If I choose 7 here, how many choices I have here? Then I left with 3 and 5, which is 2 also. So if I wanted to start from the front, then meaning that for the first place, I will have 2 choices. After I put 2 here, then what happened? Like either maybe I pick a 5 here, then after that what happened is I left with 3, 7, right? So I also have 2. Then after that, when I move on for this one, I already picked 2 number to put here. Then I left with another 2 number, which I put 2, 1. So if I start from the front, then I have 2, 2, 2 times 1, which gives me the answer 8. Okay, what's the problem now if I start from the back? So you see, I draw the same thing. So here is like 3, 5, 7, and then 5, 7. Okay, what's the problem with this is that, you see, I have these 3 choices here. If 3 get selected to be the last place, then what happened? In front, you left with 2 choices, correct? Which is 5, 7 still available. But what happened is, if I pick 5 or 7, then what happened? The choices in front, I will left with only 1, because 5 or 7 is getting selected here already. So for these cases, then what you need to do is you need to imagine or predict for both situations, then you plus them together. So like when I start from the back, okay, so you see, just now we say already we start from 3, then the outcome is going to be different, right? Okay, so maybe it's like if 3 gets selected. Okay, so if 3 gets selected, that mean what happens? So like for the final part, we already assume that 3 gets selected, so I don't have any choice. The last number here must be 3. So that's why 1 times. So if 3 gets selected here, then how many do I have for the first number? I still have 5 and 7, which gives me 2 choices. Then after I put in here, then I left with the other 2 number, which gives me 2 times 1. Then I got 4. Okay, so I didn't get finished yet because I only assume that 3 is getting selected. But how if 5? Okay, so the problem now, can you combine 5 and 7 and do it together? Yes, you can. Because why? Because if 5 gets selected, you got 1 choices here. If 7 got selected, you also have 1 choices here. So that's why you can do this together. But if you want to do it separately, you are getting the same answer, so don't worry. Okay, so if 5 or 7 is selected, then what happened? Okay, so 5 or 7 is selected, meaning that I'm assuming for the last part, how many that I have? I have 2, correct? So meaning 5 or 7. So I have 2 choices. So when 5 or 7 is selected here for the front part, I will left with 1 choices, because if 5 is selected, then I left with 7. If 7 is selected, then I left with 5. So that's why 2 times 1. Then after that, for this part, it's going to be 2, 1 also. So I get 4. So you can see 4 plus 4, I'm getting 8. So which is the same answer. So it depends on you which one you want to do. Okay, so if you are going to do 5 and 7 separately, then what do you get? So if 5 is selected, so meaning you already assuming this is 1. So 1, 1, 1 times 1 times 2 times 1, you get 2. Then you assume 7 is getting selected. 1 times 1 times 2 times 1, which gives you 2, 2. So 4 plus 2 plus 2, you are also getting 8. Okay, alright, so number 3. How many 5 digits even number greater than 40,000 can be made using the digit 1 to 5 exactly once each? Okay, so 5 digit even number 1, 2, 3, 4, 5. Okay, greater than 40,000. So from 1 to 5, the number that can make this number greater than 40,000 is I need to put 4 and 5 here, correct? Then for the end, even number. So what is the number that I need to put here so that my number become even? It's like 2 and 4. Okay, so now we face the same situation also, which your restriction, the choices that you have is like different. So that's why we need to do it separately also. Okay, so let's say the same thing, we try to do it like I will show you both. Okay, so let's say if we start from the front. Okay, if I start from the front, how many choices do I have here? I have 2 choices, which is 4 and 5. Then after that, when I move to the back, then how many choices I have? So you can realize if 4 gets selected, then I left with 1 choice. If 5 gets selected, then here I will have 2 choices. So in this case, you are going to have different choices also if the number that you are going to select it is different. So that's why we need to do it separately. So if 4 is selected, then what happened? Meaning you're assuming that the first place is going to be 4, right? So 4 meaning you have only 1 choices. So if 4 gets selected here, then how many choices you left for the space here? You left 1, so 1. Okay, so for here, you left with the other 3 digit, which doesn't matter, so meaning 3 factorial. So we give you the answer 6. Okay, so now we move on for the second choices or the second possible outcome that you have. If 5 is selected, then what happened? So if 5 is selected, meaning that the first one we already assume 5 will be selected, so we put 1. Then if 5 selected here, what happened to your last place? You still have 2 and 4 to choose, right? So that's why 2 times the same thing, the 3 number here doesn't matter, so 3 factorial. So 3 times 6, 2 times 6, which gives you 12. Okay, so your answer will be 6 plus 12 equals to 18. Okay, so the same thing if I want to do it from the back. So if I want to do this from the back, right? Then what do I have? So the same thing, if I pick 2, I have 2 choices here. If I pick 4, I have 1 choices here. So meaning both give me different possible outcome if I choose either one. So that's why I need to do this separate also. So if 2 gets selected, meaning that you're assuming the first one you get 2. Then here you left with 2 choices, then the other one doesn't matter, then equals to 12. So if 4 is selected, then what happened? The first one you also have 1. Then after that, what happened for the in front one? If 4 gets selected, right, then meaning you don't have a 4 here, you left with 5. So that's why you left with 1 choices. 3 doesn't matter, then equals to 6. So you are still getting 12 plus 6, which gives you 18. Okay, so which is the same thing. Alright, so now we move on for the next question, number 4. How many ways can 4 boys and 2 girls sit in a row if the boys and girl can sit anywhere? Okay, so this one is without any restriction because boy and girl can sit anywhere that they want. So how many objects that you are actually arranging? So 4 boys plus 2 girls, then you have 6. So that's why 6 factorial will be equals to 720. Okay, then after that B, we start the restriction. Okay, if the two girls need to sit together. Okay, so what happened here is if I try to list down the outcome that I have, right? Then meaning I have boy 1, boy 2, boy 3, boy 4, girl 1, and girl 2. Okay, so after that, meaning that these two girls must sit together. So meaning that what can we try to do is this one, they must stick together. Okay, so the other one is like we treat it as like individual because they are not restricted. So only the girl are restricted, they need to sit together. So when you look at this, right, what happened here is how many choices that you have when you want to put in. So meaning like when you want to move it together, right, you must move girl 1 and girl 2 together. Either I move girl 1, girl 2 in between B3 and B4, or I put this in between B2 and B3, or I put in between B1 and B2, or I put it in front. So what can you realize here is like the G1 and G2 actually combine and become 1. So meaning how many choices or how many objects that you are actually arranging. You have 5 here. So meaning B1 is 1, B2 is 1, B3, B4, G1, G2 is 1. So meaning that how many you have? 5 factorial. Is that okay? If I'm going to draw it out, right, then it will be, so you see this one must be together, right? So that's why I will have something like, either I put 1, 2, 3, 4, then 2 of them together, or I can have 2 of them together in front, then 1, 2, 3, 4, or I will have the first one, then after that they sit in the middle. Okay, so yeah, this is like the girl sit in the middle, then another one like 3, 1, 2, 3, 4 boys, 1, 2, 3, 4, yeah, okay, or I can put 2, then the girl sit in the middle, or I can move it again, then 1 boy, 1, 2, 3, then a girl sit here. So these are like the 5 choices that I have, so that's why it becomes 5 factorial. Okay, then after that, is that going to end here? No, because what happened is the girl here, they can change to each other, like they can exchange the place. So for inside that one, then you will have 2 factorial. So that's why you have 120 times 2, which gives you 240. Is that okay? So if you see something that tell you that they must sit together or they are at beside of each other, then what you need to do is you consider them as a group. Then after you consider them as a group, right, then you try to see whether there's possibility for them to interchange within themselves or not. Okay, so that's it. Okay, C, the 2 girls must be separated. So you see this situation is opposite to the one that sit together. So what you can do is you can use the total, which there's no restriction, boys and girls can sit anywhere, and you minus the possibility that the girls sit together, then you get the possibility that the girls must be separated. So it gives you 480. Okay, is it right? Okay, so for the 4 boys must sit together. Okay, so meaning what happened here is you have B1, B2, B3, B4. So meaning now all these 4 boys are together, then G1, G2, they can sit anywhere already. So how many distinct objects that you are having? 1, the whole thing here is 1, then 2, 3, so meaning 3 factorial. Then after that, you look at inside the group, how many that they can change to each other, then there are 4 of them, so that's why 4 factorial. Okay, then that will give you the answer, 6 times 24, which gives you 144. Okay, yeah, so the first one is like you make them as a group, so the group is considered as 1, so 1, 2, 3, 3 factorial. Then inside the group itself, you have 4 factorial also, because they can change to each other, like B1, B2, B3, B4, or like B2, B3, B4, B1, so they can change to each other, then that's why they have like 24 possibility inside. Okay, alright, number 5. Find the number of ways of arranging 6 men in a lift if there's no restriction. So this one, the same thing, 6 factorial, 720. Okay? Then B, 2 youngest men are at the far right side. So meaning you have 6 men. So 1, 2, 3, 4, 5, 6. So what happened is the 2 youngest must be at the far right side. So meaning I will put young, okay, young 1 and young 2. So meaning these 2 they must at the far right side. So meaning it's here, they cannot change their space. So now when you look at this, then how many choices that you have here? So you see this one is like you cannot do anything already, right? Because 2 youngest men are at the far right side, so meaning you are treating them as a group. They must sit together and at the far right side. Okay, so now if this is something that you cannot do anything and you cannot change them in front, right? So meaning this is something that is compulsory already. So how many choices you have? You only have 1 choices. Okay, like by putting 2 youngest men at the far right side. Then after that, the other one that you can change is the 4 men here doesn't matter. So that's why 4 factorial. And also you don't forget, when you put the 2 youngest men and the far right side, meaning that they can change each other also, they can interchange between themselves. So that's why you have 2 factorial. So that's why this answer will give you the answer 1 times 1, 2, 3, 4, 24 times 2. So which gives you 48. Okay? Alright, so the last one, the youngest man is neither at the end of the line. So meaning that I have same thing, 1, 2, 3, 4, 5, 6. So the young man is neither at the end of the line. So meaning that the young man cannot be at the first, the youngest man cannot be at the last. Okay? So how do you do this? So if we need to do this like do it in a way that we don't use anything to minus, then what you can assume is like if the young man, you cannot put it at the front, meaning the front, how many choices that you have? So you have 6 choices, right? Then you eliminate the youngest one, then you get 5. So meaning the youngest cannot sit at the front, so meaning you have 5 choices here. Then after 1 seated here already, for the last one, you have how many choices? You're left with 4. Because 1 gets selected here and the young man cannot sit at the last also, so that's why you only have 4 choices. So after these 2 men sit at the front and back, then the young man can sit any place here together with the other 3. So that's why 4 factorial. So that's why it's going to be 5 times 4 times 4 factorial, which will gives me 480. Okay? Or if you want to do the other way, that what you can try to do is, instead of finding the youngest man is neither at the end of the line, then you find out the youngest man is at the end of the line. Then you use the total to minus it. Okay? So all are right here. So like assuming that the first one, if 1, 2, 3, 4, 5, 6. Okay, if young man is seated here, so meaning what you assume, the first one you only have 1 choices here, right? Then the other one you don't care. So meaning you have 5 factorial. So that's why y times 5 factorial gives you 120. Same thing, but this one is only at one end. Then you need to consider the other situation also, where the young man is seated at last. So meaning you have 1 here, the other one you don't care. So 5 factorial, which gives you 1 times 5 factorial also equals to 120. So this is like the how many ways that can arrange if the youngest man is at the first or at the last. Then after that, what do you need to do? You use the total possible number of way minus 120 minus 120, which will gives you the answer for 80 also. Okay, so depends on which one you prefer, but both can be used. Okay, so we move to the last question for the restriction part. Okay, a railway carriage has 8 seats in two rows of 4. 6 women and 2 men want to sit in the carriage. So how many ways can they sit if the men sit together? Okay, so it will be helpful if we try to draw it out how the carriage look like. So they have 8 seats in 2 rows of 4. So I'm assuming something like this. So you have 2 rows. Then they are sitting like this. Okay, so you have total 8 people want to sit in the carriage. So A is like how many ways if the men sit together. Okay, so what you can assume is, I'll assume it like this. Okay, so am I going to draw the 6th way? Okay. Yeah. Okay, you see, if the men want to sit together, right? Meaning what are you assuming? So, oops. Okay, there are 2 men together, right? If they want to sit together, then how many do they have? Okay, I use different color, hopefully you can see that. Okay, so you see, either I sit here and here, correct? Second one, either I sit here and here. Is that okay? Then after that, I left with, I also can sit here and here. So same thing, I can sit here and here, or I can sit here and here, or I can sit here and here. So meaning how many possible outcome that I have. I can sit here, which is 1, 2, 3. Okay? 4, 5, 6. Is that alright? So you have 6 possible arrangement that the man actually can sit. So you have the first 6. Like 6 choices of seat if they want to sit together. Okay, so now for the man part we settle, right? So for the man part you have 6 seats to choose, and what happened is the men can interchange themselves. Like they sit together, so like man 1, man 2, it can be man 2, man 1, and that makes different arrangement also. So 6 times 2. This is basically for the man. So if the men want to sit together, they have 1, 2, 3, 4, 5, 6 choices, and the 2 here come from they can interchange themselves. Then after that, you didn't finish yet. This is like how many ways that the men can sit together, but how about the women? Yeah, so like the women can take any seat that they want. So imagine after the men take the space, right, then how many space that you have for the other women is like left with 6 space. So that's why 6 factorial. Okay, so the 6 factorial meaning like the women can sit anywhere they want. Then after that you times everything together, then 6 times 2 times 720, which gives you 8640. Okay, I repeat again. The 6 here is like how many arrangement for boys. 2 is like the men want to interchange themselves. 6 factorial is the number of ways for the women, because they can take any seat that they want. So that makes different arrangement also. Okay, so for the B, it's like when the men want to sit opposite to each other. Okay, I guess this will be easier to understand. Okay, so so when they go into the carriage and they want to take a seat and they want to sit opposite each other, then how many choices that they have? They have 1, either 2 of them sit here, either 2 of them sit here, either 2 of them sit here, or 2 of them sit here. So you can see how many choices they have. 4. Okay, then after that what happened here is so man 1 can sit here, man 2 can sit here, then of course man 2 can sit here, man 1 can sit there also. So meaning that they can interchange themselves, so you need to times 2. So the same thing happened for women, then they can take any place that they want, so 6 factorial, which gives you 8 times 720, which is 5760. Okay, so I hope you can understand it. Yeah. Okay, so we move on for the next part. Okay, so next part is permutation of n objects with repetition. So meaning that what happened here is like, for let's say I wrote down the example here. Okay, so when you have like this is like the 2 set of cards. So normally if you have something like A, B, C, D, E, if you try to arrange them, then you do not, and when you do not have any restriction, then when you want to arrange the 5 thing, that what happens is you will put 5 factorial, then you get your answer, right? Okay, but after that, what happens if I have a set of card like this? So if I have something that repeat for the objects that actually I want to arrange, is that make any difference if I, like, this is A1, this is A2, like for example, but they are meaning A, but it's just that, okay, for example, I don't use A1, A2 lah. Okay, like A, B, C, D, then A also. I use different color to differentiate it. Okay, let's say if I have something like this, is this going to be the same thing if I rearrange it like this? It still means the same, right? Because it's still A and A. It's just that, like, maybe I try to change them over. So it's still going to give you the same answer. So that's why what happened here is like there is no meaning if you want to interchange for the part that you have the repeated element. So meaning, like, for example, it's just like the, what is that called? It's just like the restricted case that we have just now. Like when you want to arrange 2 men sitting together, so man 1 and man 2, like they sit at the front and the back, or like M2 first, then after that M1, it makes difference. But now it's like you have A and A, like whether A in front or A behind, A in front, A behind is going to be like the exactly same thing. So that's why if you have something like this, then number of possible arrangement for your objects is going to be reduced. Like meaning, what is the number that going to be reduced is that the chances that they interchange with each other. So that's why when I do 5 factorial for this case, it will be 5 factorial divided by 2 factorial. So why divide by 2 factorial? Because it's going to be the same if I interchange A and A. So the part that I have A and A interchange is like 2 factorial. So the same thing, if I have something like A, I'm going to arrange A, then A, B, C. Okay, so is that going to be the same thing if I rewrite everything like this? C, B, C, and then maybe I put A here, and then A here, A here. Okay, so you see, even though like I use the number, like I use the color to exchange their position, but is that still going to be A? So everything here is still A, B, C. So it doesn't make any difference. So how do I find like how many number of possible arrangement I have? It's like 5 factorial. Now how many factorial I need to divide? So I need to exclude the part that it is meaningless for A to interchange themselves. So what is the number of arrangement for A going to interchange themselves? Is 3 factorial. Okay, so that's why where we have a formula here, you can try to read all this by yourself. So you have a formula here is when we try to arrange n objects, and P is like one type of the same, Q is another type that is same, R is going to another type, then you are going to do the formula which n factorial, which mean like how many letter that you are actually arranging is like your n, then you divide by how many alphabet that is actually repeated. So like for this space you have A and A, so that's why divide by 2 factorial. So here you have 3A, so that's why you divide by 3 factorial. So you have something more like, for example, if I change everything here to be BB. Okay, so what you can realize, it's meaningless for A to interchange themselves, so I divide by 3 factorial. Now, it's also meaningless for B to interchange themselves, so I need to divide by 2 factorial also. So this is how it goes. So you just like counted like how many possible repeated number that you have, then after that you divide by that number. Okay, so now we move on for the example part. Okay, so now we move on for the example. So just to let you know, right, this formula will not be given in your statistic formula sheet. Yeah, because this is a formula, but in another case it's also something like very common sense that you what you're trying to do is you don't memorize the formula. It's just that you're just thinking of what is the possibility that the what is a possibility that it is meaningless for some of the component in your objects that going to make like interchange. So meaning like if you have 3a, meaning that the arrangement of like the 3a interchange within themselves is meaningless, so that's why you divide by 3 factorial. That's the case. Okay, so like for a, so find the number of distinct permutation of the letter of the word for Oxford. So you can realize what you have here is like you have 2o here. Okay, so I think this one is still very easy. So it's the same thing. The first one is you find out how many arrangement do you have without thinking about how many letter that is repeated yet. So meaning that you have 6 letter here, which means the number that you have is like 6 factorial. Divide by the chances that the repeated letter interchange within themselves. So you have 2o only, so that's why divide by 2 factorial. So which will gives you the answer is at 720 divided by 2, which is 360. Is that alright? Okay, so B. So you have HUA, LA. So you have A, and you have LL. So what is helpful is maybe you can write down if you want that you have 3A and you have 2L. Then the other one is like H, which doesn't, H and U, which doesn't matter, like they are, there's no repeated H and L. Okay, so after that, then you can count 1, 2, 3, 4, 5, 6. So you are arranging 7. Then you want to eliminate the chances for A to interchange themselves, which is like meaningless, and eliminate the chances for L to interchange themselves. Okay, so what's the answer that you are having is like 7 factorial. So 7 factorial will gives you 5040 divide by 3 times 2 times 2, which gives you 12. So you will be getting answer 420. Okay, so the second C, the same thing, you can try to calculate it, like how many number that you have for everything here. Okay, so after you count it, yeah, you take your own time, count it yourself. Okay, I'm just going to write it here. You have 3O, you have 3U, and you have 2A, 2G, and 1D. Okay, it'll be helpful that you write everything, then you count again. So like you have 6, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you know it's correct. Okay, so after that, so meaning everything you have 11 number, right? So 11 factorial divide by, so you want to eliminate the chances for O, for meaningless interchange for O. So 3 factorial for U, then 2 factorial for A, 2 factorial for G. So equal to 3991680 divided by 96, which is 1415800. Okay, so yeah, I think this is not like too hard. Number 2 and number 3 also. Okay, the digit 3335667 are used to make a 8-digit code. How many distinct codes that you have? Okay, so it's the same thing. So you are going to arrange all them together. So you have 8 factorial. So what's the number that actually repeated that you want to eliminate the meaningless interchange? So meaning 1, 2, 3. 3 factorial, this is for 3, then 5 is 1, then it's alright. You have 2, 6, and you have 2, 7. So equals to 40320 divided by 24, which is 1680. Okay, alright, number 3. A 16-digit code consists of 2 blocks of 8, and then the first contains 2 ones and 6 0, and the second one you have 4 ones and 4 0. How many distinct codes are there? So meaning that you are going to do this separately, like first and second, then after that you combine the code together. Okay, so for the first block you are having 2 ones and 6 0. So meaning that what is the number of arrangement that you can have for the first one? Yeah, you will have 2 blocks of 8. So meaning the first block you are going to arrange 8 number. the meaningless interchange will be 2, 1 and then 6, 0. Okay, then after that times with the second block, which you need to arrange 8 also. Then what is the meaningless interchange? 4, 1 and 4, 0. Okay, so you get equals to 40320 divided by 1440 times 40320 divided by 576. 2870, which gives you 1960. Okay, I think it's pretty easy, right? The first one is for the first block, second one is for the second block, which you are arranging like 8 digits each, and you have different meaningless interchange for your number. Yeah, so that's why you have 2 factorial, 6 factorial, 4, 4. Okay, so move on to number 4. Okay, find the number of ways for 8 letters avocados can be arranged if there's no restriction. Okay, so when you realize this, then what are the letters that actually get repeated here? Yeah, so you have 2O and 2A here. Okay, can you see that? Like you have 2O and 2A. Then the other one is like all single, like 1V, 1C, 1D and 1S. Okay, so total 8 numbers. So if there's no restriction, meaning that 8 factorial will be divided by meaningless one will be 2O and 2A. So equals to 40320 divided by 4, which gives you 10080. Okay, which is the answer for the first one. Okay, B, the word must start and end with O. Okay, I'm going to draw it out. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this one, the word must be start and end with O, meaning here is O, here also O. Okay, so do you have any choice here? When you write O here, then of course you left O here, right? But there is no meaning for you to interchange themselves also. So that's why you have only like 1 choices here. You have only 1 choices here also, which here you must put O, this one also must put O. So after that, what happened is we check for the in-between one, so for this part. So for this part, then how many number that you need to arrange here? It's going to be like 6, right? So 6 factorial. So how many, do you have any repeated letter that you are going to arrange here? Yes. After you put O, then you still left with 2A. So that's why divide by 2, meaningless interchange for A. Okay, so this is how you get 720 divided by 2, which gives you 360. Okay, C, the O's must be placed together. So it's the same thing like when we do the restriction just now, when the man or the girl need to sit together like that. Okay, so the O must be placed together, meaning you have 8 now. So if the O must be together, right, meaning they are counted as 1. So meaning like 1, then the other letter you left will be 6. 1, 2, 3, 4, 5, 6. Is that okay? Because the O must be together, so you treat them as one object. So 1, 2, 3, 4, 5, 6, 7. So they can interchange themselves, so that's why 7 factorial. Is that okay? Then after that, do you have something that you need to do? Okay, so you see in between this group, right, is O and O. So do you need to times 2 for this case? Do you need to times 2 factorial like what we have done just now? No, because O and O, if interchange is still O and O, so it doesn't matter. But for the space here, you have 2A also, so that's why 7 factorial divided by 2 factorial. So 720 divided by 2, which gives you 360. Okay, yeah, I hope that you can get the idea. Yeah, number 5 is going to be like a little bit more complicated. Okay, number 8, if there is no restriction, so you want to arrange this all 10 letters in breadboard. Okay, so same thing, the first thing that you need to do is count everything first. So I already count, so I will write down, or you count it yourself also. You have 2B, 2R, then 2A, 2D, 1E, and 1O. Okay? Alright, so after that, if there's no restriction, there are a total of 10 letters. divide by the meaningless interchange 2, 2, 2, 2. Okay, so in total it's like 3628800 divided by 16, which gives you 226800. Okay, so move on for B. So what if all the vowels are next to each other? Okay, so you see what is the vowel that you have? It's either A, E, and O. So meaning A, E, and O must be placed together. Okay, so I'm going to write it like this. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So what happened here is the vowel must be next to each other. Okay, so now meaning like they are the one object that is like must be staying together. So how many distinct objects that you are having? 1, 2, 3, 4, 5, 6, 7, correct? 7 factorial. So meaning because they must stay together for this 4 vowel. So for the other consonant it doesn't matter, so that's why they can put like in any space in between the consonant. So you have 7 factorial. Then after that, what do you need to do? So you check here already, you have 7, right? Then meaning that do you have anything that is repeated like outside here? When you try to arrange everything. Okay, now we are not looking inside this group yet. We are looking at the big picture. So we are treating this as 1, so we don't care about that. So this is like the whole thing is like 1, then 2, 3, 4, 5, 6. So 7. So 7 factorial. So within this 7 factorial, do you have anything that makes meaningless interchange? Yes. 2b and 2r. So that's why 7 factorial divided by 2, 2. 2b, 2r, sorry, and 2d. Okay, I repeat again, 7 factorial is like we treat the vowel together, and then after that, so we have 1, 2, 3, 4, 5, 6, 7. So divide by 2 factorial, 2 factorial, 2 factorial is because of we have like meaningless interchange for 2b, 2r, and 2d. Okay, after that, is that only? No, because you didn't care about what is happened inside also. Okay, so what is happened inside, you have different vowel that is like A, E, and O. So how many arrangement that you are making is going to be 4 factorial, but then you have 2 meaningless interchange here, which is your A. So that's why divide by 2 factorial. So equals to 5040 divided by 8 times 24 divided by 2, which is 630 times 12, which is 7560. Okay, I hope that you can get the idea though. Yeah, you just understand the step and like what is the possible arrangement or the outcome that you can make, then you should be able to do it. Okay, if E and B must be at the two ends respectively, so we have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now we say that this thing A and B must be at the two ends. So meaning here you put E or B. Here also it can be E or B. Okay, so now when we talk about the two ends, how many choices that we have? So if you put E here, then it's B here. So if you put B here, then it's E here. So you have 2 choices. Is that okay? Or you want to put 2 factorial also can, because like here you got 2 choices. After 1 has been put here, then the other one you left 1 lah. So 2 factorial and 2 is the same thing. Okay, then after that you deal with what is happened inside. So here the end you already fixed is something that you cannot change already, so that's why you do not take into account for this 2. So what happened here is you left with 8 arrangement inside. So within the 8 arrangement inside, do you have any meaningless interchange? Yeah, so do you still have 2b? No, because you already put 1b at the end already. So 2, the b you only left with 1 for the 8 letter here. So the b is not considered. So that's why for 2r, 2a, and 2d. Okay? And you will be getting equals to 2 times 40320 divided by 8, which gives you 10080. Okay? Is that alright? Yeah. Okay, so we'll be moving on to the last part already. Okay, so I hope you get the idea. Okay, so the 2 is for the front and the end. Then after that, this part is for what happened in the middle. Okay, last page. The word international has 4 consonants N, T, R, and L, and 4 vowel I, E, A, and O. Find the number of different arrangements that will use all 13 letters. Okay, so I think what is helpful here, because it's very difficult for us to see, so what will be helpful is to try to count everything first, then before you do anything. And when you check, then after this they need to find a pattern of vowel and consonant, and since they already give us like the list of the alphabet, then it will be helpful that you write a row for vowel and write another row for consonant maybe. Okay, so N, T, R, L, then you can count it. So you have 3N, 2T, 1R, and 1L also. So for the vowel part, you actually have 2I, and you have 1E, 2A, and 1O. Okay, so A, find the number of different arrangements that will use all 13 letters. So this one is without any restriction, it's just that you need to arrange everything. So make sure that you count so everything is correct. 3, 2, 1, 1, 7, 6, so 13, yeah, correct. Okay, so 13 factorial divide by the meaningless interchange, which is your N, your T, your I, and your A. So which will give you 62270208000 divide by 48, which is 129726900. Okay, so that will be your answer for A. Okay, B. How many of the 13 letter arrangement from 1 actually start with a consonant and have a alternating pattern of a vowel and a consonant and a vowel and so on? So meaning what happened here is, if I'm going to draw it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so we start from a consonant first. So the first one, it must be consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. Then you count and see, is that correct? You have 7 consonant, 1, 2, 3, 4, 5, 6, 7, which is correct. Then you have 6 vowel. Yeah, that is fine. Okay, so what is the arrangement that actually make this? Okay, then what you can try to think is you try to think of it in this way. So we settle first for the consonant part. So meaning like here, 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 and here. Okay, so imagine the first one, how many choices you have? You have 7. After you put in 1 consonant, then you have 6. 5, 4, 3, 2, 1, correct? So you have 7 factorial for the arrangement for consonant. But do you have the meaningless interchange? Because you have repeated consonant, right? So in this case, it's 3N and 2T. So that's why divide by 3N, which is 3 factorial, and 2 factorial, which gives me 5040 divided by 12 equals to 420. Okay, that is for the vowel part. Then, that's for the consonant part. So let's move on for the vowel part. So the vowel is like 1, 2, 3, 4, 5, 6. So you have 6 arrangement. Divide by how many meaningless interchange that you have? 2I and 2A. So that's why 2 divided by 2 factorial and 2 factorial, which gives you 720 divided by 4 equals to 180. Okay, now you have these 2 answers already. My question is, do you add it up or do you multiply them? Okay, so the question is like this. Are you saying the same situation or you are saying different situation? If you only arrange, so for the first one, it's like you only arrange consonant, right? The second one is you only arrange vowel. So they are actually talking like different thing, but for the outcome that you are going to produce, it is only complete if you combine them together, right? You get what I mean? Mean like one is for consonant, one is for vowel. I cannot I mean the part for the consonant is not complete without vowel. They cannot stand itself, so that's why it's going to be multiplied. Okay, then I will be getting my answer is 420 times 180. I get 75600. Okay, what is the part that actually plus? Okay, maybe I use a bit of time to talk about this. So you remember just now we have a question like this one. Okay, so when you look at this one, right, you remember just now we have the question that we talk about the front and back, then we use plus together. Okay, why is this plus and why is this times? Okay, the idea of plus is that when you actually predicted for one situation, the situation is actually already completed without the other one. Okay, so like for 3 is selected, right, I actually make a complete image here, which like if I select 3, then I have 5 and 7 here, and I have 2, I have 1. So I already arrange all of my spaces. This is like a complete one. So 5 and 7 also, I arrange 5 and 7 here, then after that I left 2, then I have 1 and 2. Also, I already arrange for every space here. So it's like 4 and 4. They stand alone. Like it's already give me a complete picture. Yeah, so that's why I use 4 plus 4. They are talking about different possibility. But for this one, I'm not talking about the same possibility. Like I arrange consonant and I arrange vowel. They need to be together, then only I finish the whole picture. I cannot say that like 420 it can stand alone, that without vowel it gives me a complete picture, because I need to arrange all 13. So they are actually talking about the same situation. It is the same possibility that we are talking about. So that's why we use times. So you can see like everything that mostly of the question that we have, actually we use times, because we are talking about the same possibility. Yeah, it's just that we can combine everything together to give us a complete picture. But for this one, it's like we are talking about different possibility. Even like 3 is getting selected, 5 or 7 is getting selected. So they will bring me to different outcomes. So that's why I need to do it separately and I plus them together. But this one, I'm talking about the same thing. So that's why I'll do multiplication. Okay? Yeah, it's the same thing about the block that we did just now. The block of the question, like the 16-digit code. Yeah, so when you look at this, right, the first block of 8 number, they cannot stand alone. Like I need to arrange a 16-digit code, so I need to have both parts. So that's why I will multiply them together, because I'm talking about these two give me a complete picture. So the first one is not complete without the second part. The second part is not complete without the first part. So that's why I need to times them together to give me like the 16-digit code. Okay? I hope you can understand what I'm talking about. Alright, okay, 7. There are 10 empty car parks at the shop lot. There are 6 cars on a particular day. How many ways are there to park the 6 cars into the space? Okay, so meaning what happened here is you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. So like for example, you have 6 car, right? So what I'm going to do here is I will try to label the 6 car A, B, C, D, E, F. Okay, then A, B, C, D, E, F. Okay, if no restriction, meaning like all the car can take any spaces, right? So meaning how many choice I have? I have 10 factorial, because I have 10 spaces, right? But what happened here is like you have 4 spaces. This is like empty, 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 empty. So for the empty one, is that going to be like meaningless interchange? Yes. So if like I put everything here, if I interchange within themselves, it's going to be empty space also. So that's why I divide by 4 factorial. So it gives me 3628800 divided by 24, which is 151200. Is that okay? Different car makes different arrangement, but empty space make up the same thing. So like empty space 1, empty space 2, 3, 4 is the same thing when I say empty space 4, 2, 3, 1 like that. Okay? So B, the 4 empty space are to be together. So like in this case, you have 4 empty space together. So what happened here is when we put everything into 1, so meaning I assume the 4 empty space together, 1, 2, 3, 4. Then after that, I have 6 car. Okay, so meaning we are treating them in 7 groups, so 7 factorial. So do you still have anything? No, because within the empty space, that's meaningless for them to interchange each other. So there's no point that you want to arrange it. Then after that, you already arranged the space for everything, right? So only 7 factorial, so equals to 5040. Okay, so I hope you can like grab the idea of everything. Then that's it for the first part of this lesson. So for the next class, we are going to see for the permutation or the combination, which you will select a number of objects from the n objects that you have. Meaning like if you have 5, then you're going to select only 3 and so on. Okay, so that's it. Thanks for watching, and yeah, continue your exercise.